Let's look at an Excel example of the concepts we've discussed so far. We're going to use problem number 9.14. So the quality control manager at compact fluorescent light bulb. So we looked at an example like this in the previous chapter. And we want to determine whether the mean life of a large shipment is equal to 7,500 hours. So we want to test whether the mean life is 7,500 or not. So this is a two-tailed test. Mu is 7,500, mu not equal to 7,500 is what we want to test. And here the population standard deviation is assumed to be 1,000. It's given as 1,000. A random sample of 64, so n is 64, gave us a sample mean life of 7,250. And at alpha of 0.05, we want to decide whether it is, whether we can reject the null hypothesis or not, and we want to compute the p-value as well. Okay, so let's first define what x is, what mu is, what sigma is, and that is the context in which the numbers will make sense. So it is always important to define the variables. So here x is the life of a compact fluorescent light bulb in hours. So mu is the average life and sigma is the standard deviation. Now we are given that sigma is 1,000. Now sample summary is again given. We have a sample of 64 and x bar for the sample is 7,250. Now we want the hypothesis whether the mean is 7,500 or not. Now I want you to put the hypothesis in this fashion, okay, and you have to do it in this way. If you don't do it in this way, you are liable to get points deducted. The hypothesized value for mean should be entered in a separate individual cell because we need that value for computations later on. Okay, and then you change this to the question mark should be changed to what type of hypothesis that we want to test. Okay, so mu equal to 7,500 goes separately. Don't put mu equal to 7,500 like that and leave this cell blank. Then you can't use 7,500 in formulas. Okay, then the alternative hypothesis H sub 1 is mu not equal to, so you can insert not equal to, you can go to insert symbol not equal to, okay, 7,500. So that's the opposite of null hypothesis. Alpha is given as 5%. So now sigma over square root of n is sigma is given divided by square root of n. Okay, and then the z stat, okay, z stat formula is right here. Okay, x bar minus mu. So here we are able to now click on C17. That's the reason why the hypothesized value of mu should be in a separate cell, so we can use it in this formula. Divided by standard error is sigma over square root of n. Okay, which is minus 2. Now for us to be able to use z table, the normal distribution table, we need the z stat to follow normal distribution or x bar to follow normal distribution. Now x bar will follow normal distribution in this case because n is 64. Sample is large, so x bar will be so close to normal, is indistinguishable from normal, irrespective of what the population is. So the life of the fluorescent light bulb distribution, you don't care. Since sample size is large, no assumptions are needed. If the sample size is small, then we have to worry about whether the underlying population is normal or not. Now z table, okay, is now we need to, here is the alpha, and you need to worry about whether it is one tail or two tail. So when you have not equal to, we have two tail test. So this will be norm dot S dot INV, okay, 1 minus alpha over 2. Okay. Now, in a two-tailed test, you have both the positive side and the negative side. So, your conclusion here is, since the absolute value of z is greater than z table, we reject the null hypothesis. So, in a two-tailed test, you have to take the absolute value. Okay. In a one-tailed test, it will be as is. But in a two-tailed test, you take the absolute value of z stat, and that is greater than z table, and therefore we reject the null hypothesis. So that's the conclusion. Now, if you want p-value approach is you want to find the tail area, and then for a two-tailed test, you have to multiply the tail area by 2 because there are two tails. So tail area for the z statistic. So this is a negative value. So tail area here is norm dot s dot dist. Okay. And for a negative value, the cumulative probability is the tail area. So we can simply use the negative value, okay, and comma 1 for cumulative. And that's only one tail. So you have to multiply by 2, and that will give you the two-tailed value. We'll convert that to a percentage. So now the conclusion is, since the p-value is less than alpha, okay, the probability of committing type 1 error is small enough that we can go ahead and take the risk of rejecting the null hypothesis. So now we have to interpret. You can't just simply leave the conclusion as is. You have to interpret and then say, and the interpretation should have two parts. One is, what is the conclusion? What does it mean? And the second part is about the probability of type 1 error. So this means we have sufficient sample evidence to conclude that the mean life is not 7,500. So we are rejecting the null, going with the alternative. Okay. Now, once we have taken that stand, then you say the probability that we are wrong. Okay, I'm taking this stand, but I may be wrong, but that probability is really small. It's only 4.6%. So we have sufficient sample evidence to conclude the average life of the compact fluorescent bulbs in the shipment is different from 7,500. And the probability that this conclusion is wrong, which is the type 1 error, is 4.55%.